Hi, thanks for clicking on this. The idea I'd like to get across to you is quite complex. Without trying to sound melodramatic though, it's very important for as many people as possible to try and understand this, if what I'm saying is correct. Because it could quite literally be a matter of life and death for you. I know that sounds unbelievable, but you be the judge. I'll give you all the scientific evidence and then make up your mind for yourself. First, I'd like you to try to put you in the right frame of mind to imagine you were living roughly 400 years ago. Say in Europe, you're a farmer or a tradesperson. You look up at the night sky and what do you see? You see the stars going around their usual path, rotating around you, of course, and the church has been telling you you're in the middle of the universe, and you think, well, that's fine, it's true, you can go out and see it at night, it's obvious. And then along come Copernicus, Kepler, and ultimately Galileo, who has the audacity to prove to the world that that isn't true, that the sun is the middle of the solar system, that the Earth in fact is rotating around its own axis and travelling around the sun. What? We're moving around in space and spinning? That can't be. I can't feel anything. Well, that's how people felt at the time. It was totally unbelievable. But through calculations from Galileo and observations, it was proven to be fact. And over the last several hundred years, we've all come to believe that this is true through observations from space travel and what have you. I'm about to give you a chance to experience that same kind of this can't be true experience. Please try and imagine the following. I'll bring out my low budget special effects. That's why I needed the low light to try and get this across. Have a look at these two galaxies. They're spiral galaxies. Let's say, for the argument's sake, they're 100,000 light years across. How far apart would you say they were? Roughly 5 galaxy diameters. Okay, that makes them 500,000 light years apart. Hold that thought. Okay, now I'd like you to have a look at the next two galaxies. Have a look at these. How far apart do you think they are? About 10 galaxy diameters. If a galaxy's 100,000 light years across, that makes them about 1,000,000 light years apart. Okay, now I'd like you to have a look at all of them. What do you see? The top two galaxies, if I can fit them into the picture, are exactly the same as the ones below. The only difference is they've contracted by half their diameter. They're not actually moving at all, but they're comparatively further apart due to their contraction. Okay, again, pardon the special effects, it's the best I could do. Now imagine that those galaxies are not 100,000 or 1,000,000 light years apart. Imagine that they're 1,000,000,000 light years apart. The same effect applies. If they contract by half their diameter, they are suddenly 2 billion light years apart, and not just 1,000,000,000. What I've just shown to you is what Edwin Hubble saw in the early 20th century, and he published on January 1st in 1925 his observations, which led to the creation of the theory of the Big Bang. What he observed was Hubble's law. The degree of redshift observed in light coming from a galaxy increased in proportion to the distance of that galaxy from the Milky Way. The same mathematical principle that I've just explained to you in very simple terms. Except Hubble, of course, thought, looking through his Wilson telescope, well, this redshift, it must be due to the galaxies receding. What is redshift? You probably know it as the Doppler effect. The Doppler effect is, for example, the sound of a train coming towards you, passing you, and sounding different as soon as it has passed you. On approach, the sound has a higher pitch. When it's receding from you, it's a lower pitch. The same thing happens with light. And Hubble saw redshifts. Redshifts means things are travelling away from us, or so he thought. That was the only possible explanation. But is it? He didn't for a minute think that the size of galaxies could be contracting. Well, why would you? We're the measure of all things. 400 years ago, we wouldn't have believed the world was turning. How could it be? Everything's revolving around us. Well, Hubble automatically thought there's redshift, things are travelling away. How could he have guessed things may be contracting and nothing is moving away at all, at least not the way they thought it was? That is, in a nutshell, what I'd refer to as the contracting matter theory. If all the matter in the universe is contracting at the same speed, I don't just mean orbit decay of atoms, I mean every single particle that was created at the moment of creation, whatever that now may be. The implication of that is our scientists may have it totally wrong. Well, I find it hard to believe that this idea hasn't been thought of before. Maybe it has been. I don't know, but I can't find any great reference to it. And there'll be a reason for that. I'll explain that reason. If you think of the Big Bang, if Hubble thought everything was moving away from us, then of course at one stage it was all a whole lot closer together. That's what brought about the Big Bang theory that Lemaitre proposed, and which now is widely accepted as if it's almost a truth, but it is, remember, only just a theory. There are other so-called evidences for it. I will show you how they fit in with this contracting matter theory, and that is actually more likely even than the Big Bang. But let's just hold it there. What's the implication? The Big Bang is everything came from a very, very tiny space where the whole matter of the universe was compressed into what they say the space of less than an atom, as they never cease to explain. If nothing is actually moving at all and all matter is contracting at the same rate, then that means that at one stage all the matter was very, very, very much bigger. That means that the universe is actually eternal, it is infinite, and there was no Big Bang, and that matter was created out of it in a very, very different way. Now this is fundamental to one thing that is very important at the moment, and that is our understanding of matter and how it relates to the Large Hadron Collider, which is currently operating in Geneva. This can mean a heck of a lot in regard to that. I'll try and explain more in the next little clips. Thanks for watching.